Today what we're gonna do is the last lesson before actually doing the proofs tomorrow, which are the algebra ones. And today what we're gonna learn is some postulates that have to do with lines and planes and points, and not things that are hard to understand. They're pretty self-explanatory. So normally when we get to proofs, if there's like for every step you do in a proof, you have to give a reason. And if something is used a lot in proofs, it'll have a name for it. It'll say like segment addition postulate, vertical angles theorem, linear pair postulate, something like that. The ones that we're learning today, the postulates that we're learning, don't have a specific name, and that is because we don't use them again after this lesson. So instead of naming them, they number them. So because we don't use these after today, and we don't have to remember what is 2-1, what is 2-2, for today, for your answers, I'm gonna let you just write 2.1, 2.2, 2.3, okay? So let's talk about what each of these says. So first of all, for 2.1, what it says is if you have 2 points, you can draw exactly one line through those 2 points. Okay, so that is just, kind of obvious, but yet it's a postulate, which I should explain too. A postulate in geometry is like a scientific law in science. Then it says, through any non-collinear points, there is exactly one plane. So notice A, B, and C in this diagram are not on the same line, and you can draw one plane through there. One thing that is a little confusing is if you had 2 Skittles on the floor and you held the Skittle here, do you think I could draw a plane that would go through those 3? What do you get? I could slice a plane that would go through this Skittle as well as the 2 on the floor. So through any 3 non-collinear points, you can draw exactly one plane. Then if we look at 2.3, this one is kind of related to 2.1. It says if you have a line, then we know you have at least 2 points. You could have 1,000 points on that line, but we know for sure that you have at least 2. Now, one thing that's a little confusing today is if they're talking about points and a line, like are they referring to 2-1 or 2-3? I don't get really worried about which one you choose. So if the answer was 2-1 and you told me 2-3 or vice versa, that would be fine, okay? Same thing with 2.4. It says here, a plane contains at least 3 non-collinear points. So anytime we have a plane, we know that we have at least 3 points that are not on the same line. Okay, now 2.2 and 2.4 are also very similar. They're like converses of one another. So because of that, if the book said 2.2 and you said 2.4 or vice versa, that would be okay. All right. Now let's look here. It says if 2 points lie in a plane, then the entire line containing those points lies in that plane. Okay, so here, if you have a line, I'm lying. If you have 2 points, okay, so let's say we have A and B, and if those 2 points are in a plane, and we drew a line between these 2 points, the line would also lie in the plane. So it'd be like if I had two Skittles on the floor and I connected them with a line, the line would also be in the plane of the floor, okay? 2.6 talks about if you have two lines that intersect, which we don't always, right? Two lines don't have to intersect, but if they do, they intersect in one point, okay? We have parallel lines that don't intersect, but if they do intersect, it's one point. And then 2.7, I would never make you draw this, but this is what it would look like if we could draw two planes. So if I drew this plane on the front wall up into the upstairs, and we took this ceiling and moved it into Mr. Check's room, and we thought of the up plane and the across plane and where they intersect in a line, okay? It's a little bit easier to see if you just think of the front wall as one plane and the ceiling as one plane. You can tell they intersect in this line up here. So you just have to know if two planes intersect, they intersect in a line. All right, so the first part of your assignment today, you're going to get a diagram like something like this, and they're gonna ask you to state the postulate that can be used to show each statement is true. And you can just say 2-1, 2-2, 2-3, whatever it is. So this first one says lines N and P, here's N, here's P, intersect at point D. Which postulate talked about if two lines intersect, they intersect in a point? 2.6. 2.6. So that is all you would write down. Okay, so you're just trying to find which one would that be. All right, the next one says points A, B, and D form a plane. So here's A, here's B, here's D. They're all in this front rectangular plane. And you can notice that those 3 points do not lie on the same line. So which one talks about if you have 3 points that are not on the same line, you're gonna have a plane? 2-2 or 2-4, right? Don't those kind of mean the same thing? So we're gonna, you can write whichever one. I would accept both. Okay? So don't worry about it if you have 2-2 and the book has 2-4, you're fine. Okay? The next thing says points A, B, and C are points that make up line J. Now, one of these, so I think I just don't have that part on here, but one of these lines is J. It's this one right here. And it says that those 3 points are on line J. Which one talked about if you have a line, it's gonna contain at least 2 points? 2.3. 2.3, and if you put 2.1, that is fine. Okay, I don't get too worried about that. Then it says the plane that contains A, D, and E, the plane that contains A, D, and E, which is this front one here. Oh, that color's not gonna show up. So this front one, and then they say, and the plane that contains F, G, and E, which is this one, intersect in line K. And like I said, this right here must be K. This line is J. So which one talks about if you have 2 planes that intersect, they intersect in a line? 2.7? Okay. All right. Now let's go down to this problem here, and it's the same thing. You're just gonna write 2, 1, 2, 2, 2, 3. And this first one says, exactly one plane contains F, B, and E. When you first look at F, B, and E, you might think there's not a plane that goes through there, okay? However, let's check if there is a plane that would go through there, okay? Is there a plane that would slice through F, B, and E if they're not on the same line? Like, remember I said 2 skittles and 1 up here. Can you slice a plane through there? And what would that be? Through any 3 non-collinear points, there's exactly one plane. 2.2. And again, if you said 2.4, that would be fine. Okay? Now, the next thing says line BE lies in plane Q. Okay? So BE is not drawn, but we could draw it. Okay, so we can draw a line. I'm just gonna make that big so it looks like it goes through it. Okay, line BE would lie in plane Q. Which one says that? Say that again. This one is the one that talks about if 2 points are in a plane and you drew the line, then that line would lie in the plane. 2.5. Yep. 2.1 would be if they just said you could draw line BE, something like that. But here they're talking about that line lies in the plane. Okay, so if we look at example 3, we have this drawing over here, and they say G and P are collinear. And you might look at this and go, no, they're not, but you could draw a line through there. Which one says if you have 2 points, you can draw a line? 2.1 or 2.3, I would accept 2. Okay. Then it says points D, H, and P are coplanar. D, H, and P are 3 non-collinear points, and through any 3 non-collinear you can draw a plane. So which one was that? 2.2 or 2.4? Yes. Are you gonna have to memorize? No, that's a good question. On your test that you guys have coming up, you have to know, like if I said true or false, D, H, and P are collinear, you'd have to know that that's false. Or if I said the line containing P and H would lie in the plane, that's true. You don't have to give me the number of them, but you have to know what they mean to be able to solve a true or false question. Okay? So I might say like S, T, and Q, or you could draw a plane through S, T, and Q. True or false? True. I might say, since T and L are in plane A, line M is also in plane A. True, right? Okay. So that's more what it would be like. So now we have this drawing, and it says point L and T and line M. Actually, that's what I just kind of said. Point L and T and line M lie in the same plane, okay? And on the quiz, you would just have to say true or false, but here, that is true, and which one is it? 2.5 is correct. Whenever you have 2 points in a plane, you also have, hold on 1 second. Hello? Are you okay?
Yeah, absolutely.
Oh, okay.
I'm on a walk.
Oh,
I just wanted to talk to you quick. Is this a bad time?
yeah, I'm teaching.
Okay, I'm sorry about that.
No, you're okay.
Sorry about it.
No problem, bye. My son never calls me, so that kind of scared me. Okay. So, line M is this line right here. And line ST is this line right here. And it says they intersect at point T. Which one talked about if 2 lines intersect, they intersect at a point? 2.6. Okay. Now let's go to this. And this actually, I think, is what your quiz looks like. I think it's always, sometimes, or never that you're gonna write down. And you don't have to explain your reasoning, okay? So the first thing says, if 2 coplanar lines intersect, then the point of intersection lies in the same plane as the 2 lines. So you have to kind of understand what they're saying here. So they're saying 2 coplanar lines, which means both lines are in that plane, and they intersect. So would you guys know that it would look like this and this? Okay. And it says then the point of intersection here would also lie in that plane. Do you think that's always true, sometimes true, or never true? Always, yes. Okay. Then it says 4 points are non-collinear. Okay. So this is saying anytime you have 4 points, are they non-collinear? Could they be? Yes, right? Couldn't they look something like this and be non-collinear, right? So they could be, but could you also have this? Couldn't you have 4 that were collinear? So what do you think you'd write? Sometimes is correct. Okay. This one says a line contains exactly 1 point. How many points does a line contain? At least 2, right? So what would this be? Never, okay? Because a line has to contain at least 2. Okay? Here it's talking about 2 planes and they intersect in point T. Here's a plane, the ceiling's a plane. Where they intersect, is it a point? What is it? A line. So this again would be never. Okay. E says any 2 lines, L and M, intersect. Sometimes. The 2 lines could intersect, right? Like this. But couldn't they also be parallel and not intersect? So because of that, this would be sometimes. All right, 3 collinear points determine a plane. Okay, so this is saying if you have 3 points that are on the same line, that is going to determine a plane. What did the postulates say? If you have 3 what? Non-collinear points. So this one is gonna be never, and the reason is, if you think of my little marker here as a line with 3 points on it, you could slice a plane through here, you could do crossways, you could do diagonally. There's infinitely many planes you could go through this. So this one is going to be never. Okay? All right, now we're gonna get into some, this is more goes with what we're doing tomorrow, okay? And we're gonna learn some postulates that, or properties, sorry, that you are going to use on your algebra proofs. And this should not be too hard for you, okay? So first of all, as we're doing an algebra proof tomorrow, all that happens is they give you an equation and you keep solving for x, and every time you do something, you have to give a reason. I'll kind of show you one so you can see what I mean by that. I don't know if I have one that's, yeah, like this. Okay, so what, this is an algebra proof. You start with this, and it tells you the answer there is 4. And then every time you go, you have to give a reason. And I'll talk about that tomorrow. Some you wouldn't know right now, but we'll talk about that tomorrow. So what we're gonna learn today is what would those reasons be that we could use, okay? So if we give you something as easy as this tomorrow, I think you guys would all know to solve, we would add 4. And we would get x equals 11. And by the way, when you do an algebra proof, you don't show the work like this. You would just go x equals 11. And then what you would do is say what you did. And for this one, we would say addition prop. So I abbreviate a lot. So for addition property, I just say addition prop or add prop, okay? Then if I give you something like this tomorrow and you had to solve it, we would subtract 5, but we wouldn't show that, and we'd get x equals 3. And then on the blank, you would write subtraction property. Now you do have to be careful when you abbreviate subtraction because there's also a substitution property. Some kids will abbreviate this SUB and they get it wrong because I can't tell if you mean subtraction or substitution. So if you're doing subtraction, you have to go SUBTR. Then if I look at this one, this is division, and the opposite of division is going to be multiplication. How I get rid of that 5 on the bottom is I multiply by 5. And then I would get x equals 20. And what I would write there is multiplication prop. Okay? Then if I go down here, this one is multiplying. So the opposite of multiplying is dividing. So my answer would be x equals 2. And then it would be division prop. Okay? So I wouldn't abbreviate any more than I do here, but you can abbreviate, okay? All right, then we have 3 different things that we're gonna talk about that we're gonna use a lot in this chapter, and these are on your cheat sheet that you have. So the first one is reflexive property. Reflexive property is anytime something is equal to itself. So like AB equals AB. This is the measure of angle ABC equals the measure of angle ABC. It could be 5 equals 5. It could be A equals A. Anytime something is equal to itself, that is reflexive prop. And that's how I abbreviate that, okay? So that, I want you to notice, only has one equal sign. In each of these, there's only one equal sign. Now if we go to symmetric property, a lot of people call this the switch-around property, but you have to call it symmetric. So what happens here is they just take both sides of this and they switch it. It's kind of like yesterday or 2 days ago when we did converse and we switched the two sides of a sentence. It's kind of the same thing. You just take the two sides and you flip it. Now notice here we have two equal signs. Okay? So it could be something like if A equals 5, then 5 equals A. So you're just taking that and flipping it, okay? Now, the last one is called transitive property. And what I want you to notice here is these have 3 equal signs, okay? So if AB equals CD and CD equals EF, then AB equals EF. So I can get rid of these two because they're the same. It's just like law of syllogism that we did yesterday. The ending of the first one and the beginning of the second one are going to be the same. And you can cross those out and say that the outside two are equal. It's similar to law of syllogism. This one is the same way. Notice the ending of the first equation, beginning of the second are the same. So we cross those out and the outside two are equal. And how I abbreviate that is transprop. Let's see if I showed you. No. Symmetric, I do SYMM prop. Okay. So, then we have two more. There is one that's called substitution, and you guys are familiar with substitution because you've done it in algebra and stuff. But whenever you have 3 equal signs, so notice this one also has 3 equal signs, how you tell between substitution and transitive is in transitive, the ending of the first and the beginning of the second have to be the same. In substitution, they're not going to be the same. So the ending of this and the beginning of that are not the same, okay? So that means we can't do transitive. What happened in this question is they gave you an equation and then they told you that x is 5. So you're going to hear me talk a lot about taking one thing out and putting something else in for that. And that's what they did here. Now they have 5 plus y equals 10. And that is substitution. And that's how we're going to abbreviate substitution and then prop. You really have to be careful with subtraction and substitution. Subtraction was SUBTR, substitution is SUBST. Then our last one should be one that you're familiar with, and that is distributive. If you have a number outside of parentheses, we distribute, so we'd go 3 times x plus 3 times y, and that is distributive property. And for that one, I do DIST prop. Okay. Now, last page, they are going to give us questions, and we just have to tell them which property we're going to use. If we look at this one, I want you to notice it has 3 equal signs. When something has 3 equal signs, it's either transitive or substitution. Which one is this? Trans. And it's because the ending of this and beginning of that are the same, so we forget about those. And then this is transitive property. Okay? Then here, if you are, this is asking you, like if you're solving this in algebra and you have to start on the left, what would you do to both sides here to get this? You would divide, right? You divide both sides by 7, and that's how they get x equals 4, and then you'd go division prop. Now on your assignment and on the quiz, you have to say prop. Kids don't, and then they lose a lot of points. Okay, start on the left. What would you guys do here to get this? Subtract. You'd be subtracting 5. So remember, subtraction is SUBTR prop. Okay. Then if I look at D, can you guys tell this one, they flipped? Do you remember what we called that? Switch around? It's symmetric. And symmetric, we did SYMM prop. Okay. If I start on the left, what would I do to both sides of this to get this? Multiply by 3, yes. And you don't have to show it, but yes, you're right, multiplication prop. How about F, what would I do? Add 7, yes. And you would get x equals 17, so that's addition prop. Okay. How about G? Reflexive. Both of those are equal to itself and only has one equal sign. So anytime something is equal to itself, it's reflexive. What about this one? Yeah, distributive. So we are just going to go DIST prop. Okay, and then what if I go to that last one? It has 3 equal signs. Whenever you see 3 equal signs, it's either transitive or substitution. Is this transitive?
Substitution.
Yeah, it's not transitive because these two are not the same. So basically what they did here is they picked out this CD and they put 5 in there. And that is transitive prop. Okay, or no, not trans, I'm sorry. Substitution. Sorry. And remember, substitution is SUBST. So your assignment is this. Sometimes in the book you won't have a reason to give, but if you are using one of those first 7 postulates or one of the properties I just went over, then you're gonna give a reason. If you don't use any of those, don't worry about saying why, okay?